Hey Math 1, I've got a new video for you. We're pretty much just extending the lesson from what you've seen in 4.1, 4.2, and 4.3. We talked about plotting points and understanding rates of change at the beginning. We talked about how to graph situations that give us a starting point and a rate of change. And I also talked about writing equations. Today we're just using the linear equation, and you'll see how making a model out of this situation allows us to do a lot more than just straight up graphing things. So, I only have two scenarios here, so it should be a relatively short concept lesson for you guys. So, here's the situation. Morgan Spurlock became famous in 2002, true story, for eating McDonald's food 3 times a day for an entire month. On average, he gained about 8 pounds every 3 days. Morgan initially weighed 180 pounds at the beginning of November. All right, and you know what? I kind of fudged the numbers just a little bit on these, just to give us our own unique learning scenario here. So the first thing I want you guys to do with this is write an equation of the line representing his weight. So from the last video, you guys should have taken away that y equals the starting point okay, then you either add to or subtract from that the rate of change in fraction format multiplied by x. That's how we can create a model representing this linear function. So, our starting point would be the fact that he initially weighed 180 pounds at the beginning. So y is equal to 180. He's gaining weight, so you're going to pick the plus here for adding. And then when you see 8 pounds every 3 days, you would put 8 over 3 and multiply that times x. Now, keep in mind that we really need to define our variables. We need to say what x equals and what y equals. Now, the easiest way to determine this is x is almost always going to be time, because time is usually the independent variable. So we're given a time value, so x is going to represent time in days. Y is going to represent Morgan's over his weight. So Morgan's weight. And in the US, we use pounds, or LBS. Okay, there's part A. Write the equation of the line. We've got it based on the starting point and the rate of change, and then I just define my variables over here to make sense of things. So now, as we look at the next questions, we are using what we got in part A. Okay, so part B is saying, how long will it take him to reach 250 pounds? So, for part B, you're given the 250 pounds as your y value. You're using, okay, so for part B, you are using the equation y equals 180 pounds plus 8/3 pounds per day. You're using that equation right there. 250 pounds tells us, you know what, I think we need a little more room here. Okay, so we've got our equation. I rewrote it. That's fine. Here, let's explore the space. So y equals 180 plus 8/3 x. We've got 250 pounds. Now this is where defining your variables becomes very important, because your variable is saying y equals pounds. We are given a y value right here. Y equals 250 pounds. So y pounds is this y right here. So I'm going to replace this y value with 250. And now I'm going to solve this equation. This will give me how many days it takes Morgan to increase his weight to 250 pounds. So all we got to do now is solve this equation. Subtract 180 from both sides. 250 minus 180, that's 70 pounds, equals 8 over 3x. And now it turns into a problem from chapter 2, which it's not bad to get some review of that, right? So there's a couple different ways to talk about this. You can put 70 over 1 and just find a common denominator. So times 3 times 3. This will give you 210 over 3 equals 8x over 3. And remember, you can just ditch the denominator now. 210 is equal to 8x, and then divide by 8. At this point, you're just figuring out what 210 divided by 8 is. You can cut them in half. That'd be 105 over 4. And then I know 4 goes into 125 times. So 4 goes into 5 once more. That'd be 26 with 1/4. This is 26 1/4. So x equals 26 1/4 days based on this model right here. So it will take Morgan 26 1/4 days to reach 250 pounds. How about part C? How much will he weigh after 10 days? Where did my black marker go? Here we go. All right, so again, we're starting with y equals 180 plus 8/3 x. I would encourage you guys to rewrite this every time you use it. All right, so now we're talking 10 days. Days is an x value, so what you're doing is you're saying x equals 10. So I'm going to replace the x with 10 and figure out what 180 plus 8/3 times 10 is. Now, how do you multiply fractions? Good question, good review concepts. Put the 10 over 1. See if you can cross cancel. You can't. So then you just multiply straight across. This is going to be 80 over 3. So what's 180 plus 80 over 3? Great question. Well, 80 over 3, I think it'll be easier to work with a mixed number because then you can just add the whole number to 180 and tag along the fraction with it. So 80 divided by 3 is equal to, it ends up being 26 2/3. The reason why I could work that out quick in my head is because 81 over 3 is 27. So you're exactly 1/3 less than 27. Anyway. Y is equal to 180 plus 26 2/3. That gives us 206 if you just add the 180 and the 26. And then just tag along the 2/3. 206 2/3 Y, pounds. So I'll just use the designation LBS for pounds. So you guys see how this is going? I'm basically saying what information X or Y is this statement giving us? All right, last one. How much will he weigh at the end of the month? So oftentimes I'll ask you a question where I'm not even giving you a numerical amount. All right, it's just saying, how much will he weigh at the end of the month? Can we quantify that with a number? What's the end of the month? Well, it said it's November, right? He's starting this in November. There are 30 days in November. So we're going to say x equals 30. How much will he weigh in pounds? So y equals 180 plus 8/3 x, right? So 30 days in for the x. X is days, 30 days. That's the end of the month. We just talked about how to multiply fractions, put the 30 over 1. Can we cross cancel 30 and 3? Yes, we can. 30 divided by 3 is 10 over 1. So then you get 180 plus 80 equals y, and that gives us 260 pounds. Based on an average rate of change of 8 pounds every 3 days, that's how much you'll weigh at the end of the month. All right, this is actually taking a lot longer than I thought. But we'll just burn through the second example on this same video. Forgive me if it goes over 15 minutes. All right, we're talking Gatorade now. A large cooler of Gatorade contains 2,000 ounces of delicious Riptide Rush. That's the purple Gatorade. The spout at the bottom can release liquid at 3 ounces every 3 seconds if you just kind of like put it on, I don't know what you'd call that, the default spout setting, right? So, can we write an equation of what's going on? Well, yeah. We should have a starting point, how much Gatorade's in the cooler right away. We should have a rate at which the Gatorade is leaving the container, so I'm going to choose the subtraction on this. So let's get to it. There's 2,000 ounces of Gatorade, that's our starting point. It's releasing liquid, which means we keep the minus. 3 ounces every 2 seconds would be 3 ounces over 2 times x. There's our initial equation where x is equal to seconds in time and y represents amount of Gatorade in the cooler. In terms of ounces. Okay, so now we're using this equation for each subsequent question. This is our model to go on. And we're using the fact that x is equal to seconds, y is equal to ounces. So, for part B, I'm going to use this equation. 2,000 minus 3 halves x. Determine how much Gatorade is left in the cooler after 90 seconds. 90 seconds would be an x value. So you're basically saying x equals 90 from this situation, which means I'm plugging 90 in for that x value. Y equals 2,000 minus 3 over 2 times 90. Now again, you can put the 90 over 1. I think we've talked about this. This is the third time now multiplying fractions and whole numbers. 90 and 2 do cross cancel. 90 divided by 2, half of that's 45. Okay? And then 3 times 45 is going to be 135. So y equals 2,000 minus 135. This is how many ounces of Gatorade there are in there. So if you put 2,000 minus 135 off to the side, you can take a shortcut and say 2,000 minus 100 is 1,900, then take 35 away from that. It's going to be 1,865 ounces. But if you want to do it the old-fashioned way, you can do this. No shame in that. Y equals 1,865 ounces. A lot of Gatorade still left over there. This is either a really big cooler or a really slow spout, or both. Using the same equation. So, part C. Let's see if I can keep my equation here without having to rewrite it. Yeah, part C. Here's my equation. How long will it take for the cooler to contain 500 ounces? So, 500. Ounces is a y value. So they're saying y is equal to 500. I'm going to replace y with 500 and then solve the equation. All right, so one way to do this without messing up things with the negatives is I'm actually going to move the 3/2 x to the left side of the equation and then move the 500 to the right. It makes everything positive. You don't have to do it like that, but I don't know, it gets our x on the left. Seems to make a little more sense for people visualizing it. 2,000 minus 500 is 1,500. And again, if you want to not deal with the fractions, you can put the 1,500 over 1, create a common denominator, just double 1,500, that gives you 3,000. So 3x over 2 equals 3,000 over 2. You can ditch the 2's now and solve the equation 3x equals 3,000. Okay, divide by 3. It's going to take you 1,000 seconds to get to 500 ounces of Gatorade. So make sure that we're putting on the label just so that we're absolutely clear about what's happening here. By the way, if you wanted to turn that into minutes, because a lot of times people are like, how long is 1,000 seconds? What you do is you take 1,000 divided by 60. $100 divided by 6 is 50 over 3, which is about 16 2/3. So it's 16 2/3 minutes. So 16 minutes and 40 seconds. So yeah, this is a really big cooler of Gatorade, which is draining very slowly. All right, I think I got one more example, and then I'll let you guys go. Take a stab at the homework. All right, can we reuse our equation again? Now, you know what? Let's just start from scratch. All right, so using the equation, determine how long it will take to empty the cooler using the spout. So again, we're using the original equation every single time. Y equals 2,000 minus 3 over 2x, right? So how long will it take to empty the cooler using the spout? Now, this is usually the trickiest one for students to visualize, but think about what we're saying here. To empty the cooler, let's use proper English here. To empty the cooler means there's 0 ounces of Gatorade left. That makes sense? 0 ounces of Gatorade is an empty cooler. So they're saying your data input, the number you plug in, is Y, because Y represents ounces, equals 0. The Y value here turns to 0, and then your job is to solve the equation 0 equals 2,000 minus 3x. I'm sorry, 3 over 2x. So how do we solve that? Well, you can add 3 over 2x to both sides. You can add 0 to anything. So that's 3/2 x equals 2,000. I'm going to put the 2,000 over 1 right away. Common denominator of 2. At which point you can just say it's 3x equals 4,000. All right? I ditched the 2 denominators already, just for time purposes. All right, divide that by 3. What's 4,000 divided by 3? Well, we can just go off to the side here and work it out. 3 goes into 4 one time. 3 goes into 10 3 times. 3 goes into 10. Oh, it's one of those repeating dealios. So it's 3, 3. And then there's going to be 1/3 left over at the end. So it's 1,333 1/3 seconds. or 0.3 repeating seconds? Okay. All right, thanks for sticking around for the whole 20 minutes. I appreciate it. Good luck on the homework assignment, and please email me if you have any questions at all. Thanks for watching.